Micro. Well, what is the formula? Damen and Herren, guten Morgen. Ladies and gentlemen, good morning. Mesdames et messieurs, bonjour. I'm Etienne Derlon from Changan, Changan, UK, Technical R&D Center. So I'm going to present here as a first one the project I'm leading for 1.5 years now. It's the in-house application software for inverter. So first presentation is about software, but very linked to the electrification and e-motor control. Okay, this is the table of content. So I'm going to introduce we.CONECT because I think not a lot of people know. Some of them have seen some of former partner. What was the project, the goals for this one? What is the platform software concept? How we implement it? So it's also a way to tell the story. So it's kind of a story of the project, where we came from, with which objective, and where we are right now, and what will be the future as well. Yep. So who is Changan? Changan is quite an old industrial company, over 160 years old, actually. And it started manufacturing cars in 1984, so it's 41 years old. And also after they expanded to create joint venture with Mazda and Ford. And even now, for example, the new electrical Mazda are based on Changan car. So it's still really now, and mainly the brand got several type of brand vehicle: pure electrical, classical, and more premium like Avatar. About specifically the UK Research and Development Center, so Changan is having 10 R&D centers around the world in 6 countries. So we are in UK. UK is specialized in powertrain research and development. Initially, that was engine, so a new generation of engine from China. It was 1.5 liter 4-cylinder. And also gearbox, so they designed their own DCT and hybrid DCT. But now we are moving toward inverter software and testing. So that is our new focus. Presence in Europe, that's something that is new in terms of car. 2025 is the year where Changan has decided to come and sell car in Europe. Like a lot of other competitors in China. Now in Europe we have mainly, so we have the UK R&D Powertrain Center with some team working for the sales, design center in Italy where we had the presentation, and after some new centers, so sales in München, Changan sales company, near that the Avatar design center. Avatar is a premium brand that is manufactured in joint venture with Huawei. And there is a Netherlands sales company that more for while you have the harbor to receive the car in order before distributing it in Europe. We are starting this year with 2 cars, pure battery electric vehicle, SO5, SO7, and there is a plan for 8 further vehicles in the 3 coming years, hybrid electric vehicle, plug-in hybrid electric vehicle as well. Project goals. So here, what was the objective? Currently in Changan, we have data as a portfolio of electrified powertrain we are going to work on. In terms of single motor system, it's single EDU, front or rear, motor generator, so in order to power the range extended vehicle. And we have several dual motor systems. One is called the DHT. It's a bit like the Honda system when you have a gearbox that gets the generator and the traction motor together. And we have now also a double EDU system, rear and front. This double EDU system is going up to 800 volt as well. And the platform software we are developing objective is to provide application software for all these portfolio of inverter system with motor. Main objective for us that was to develop in-house capability to design software for inverter. Since initially in Changan, Changan was quite as before, I would say 20 years ago in EMS. They went with a supplier. Supplier is delivering everything, so the full inverter, the control board, and the application software. So at the end, you end with different projects. Each one got its dedicated software because it's provided by the supplier. So now Changan want to bring more in-house capability in software, so develop a common algorithm that can be used on several applications. So the same application software for different projects with different supplier. Also, we need to develop kind of opportunity to optimize the code generation, and also for us in UK, that was the first time that we are really working in collaboration in China. Before Changan UK, was the teams, they were developing a full project, end up near production and hand over to the development team in China. Now we really have two teams, one in UK, one in China, working together in the same project under the same database as well. Platform software concept. Yeah, this one is a little bit messy. However, I put it because when I presented the project to the senior management, that's the way I picture how we're going to manage the platform software. So with the concept of the library of model and code generation, and the different phase when we manage the configuration, compilation, and then the calibration management. And actually, I did that, and over 1 year after, when we were discussing about the evolution, the new step, I think it's my manager pick up that picture. I say, oh no, yeah, look, you were saying that 1 year ago, and actually now we are at this stage that we have actually implemented this drawing. So that's the reason why I wanted to put here. So we had a plan, we execute the plan, and after 1 year, when we go back, we say, okay, yes, that was what we planned. So that was kind of nice to see that as well. We are implementing the Autosar Classic solution for software architecture. And also, we set up all the in-house model-based software design method, toolchain and guideline. Also, as I said, initially, each project got each line, so that was very siloed organization. So now we are moving toward a more matricial approach. So that means in-house software cross projects. We are changing the way the business is working as well. So we need to have the team that forms the platform software working across different projects. So that's a new approach. That's coming with its challenge as well, but that's the evolution and what we are requested to do. Main goal from our top management is they want to go toward a decoupling between software and hardware. Implementation and continuous development. So how we did it actually? First step, we start with the basis, so I say the bricks, meaning that we start by all the rules and the method in order to design the software. Go down to the modeling, so the software component. So we start with the modeling rules, usage of the single source of design library, strict rules, and that was the basis. We start with the basis, do a baseline of models, then that will be used for code generation. All in the same way. And my main job actually as an integration lead engineer, that was to set these rules and implement it, and also follow its implementation, be sure that all the engineers are doing that. So it's not easy. That was the first step. First project we started with what we call a DHT, so it's a dual hybrid transmission, dedicated hybrid transmission with 2 motors. For this one, we put in place the project management folder via Git. So we are managing the integration of the software through different, I would say, folder in Git. So basically, it is the traceability of different bit of software is managed through a structure into Git that has been imposed, or say, by our company. For now, that was C400 volt system. For this project, we were using tools and architecture that was managed by the supplier. So we were just doing the modeling and the unit, so the software component detail software. But we were using most of the tool chain and the method from the supplier for this first project. So we started that 18 months ago. Now it's going toward production. Second project, we took over more of the integration and also the software architecture. So we are doing our own management and design of the Autosar architecture. So all the in-house software design and the architecture, Autosar architecture, are now managed internally within Changan. That's the second level. In this way, we want to be in a position to work more easily with different suppliers. So that means now we have a control. Now we achieve the control of our application software domain in order to be able to integrate that with different supplier. So that is the second step, and we are in this process now, right now. Development process. I don't know if a lot of you have worked with a Chinese company. The development process is quite tight. We have to go fast, so there is not a lot of time in terms of rollout. So that means we don't have 6 months to prepare a process and method before starting. No, we have to go straight away. Meaning, all the time we have to build the road as we go forward. So we have step by step to do step by step the implementation, the new design, and implement and do small step in terms of process and method. So each time we have a kind of a small rollout, we have to do that along the way. It's slightly different, and there is an imperative to be fast on the market. So typically this kind of project, when we start and to have the software on the market, is 18 months. Only that, near from nothing. So that means also internally we have the capability to generate the software. So often when we work on a supplier, I remember when I was in EMS in France, the software were designed by the supplier, and we will roll out every 2 to 3 months. For this kind of project, we have a requirement to be able to deliver software every 2 weeks. So that means we have the capability, all the chain tool, to compile from a base software from the supplier with our application. And we do that on a regular basis. Every 2 to 3 weeks, we have to provide and to deliver software for testing and validation. So we organize in this way. So the principle of the backlog. So we decide. We have a fixed slot, and we decide for each slot what update we are doing. It's just a matter of organization. But it's a different way to work, I would say. Here, I just want to make a focus on the fixed point investigation. We had a request also for management to try to optimize the CPU usage, mainly, in order to reduce the microcontroller resource need. So either we reduce the performance needs, so we can purchase cheap microcontroller, or for the same performance we can put more content. And one of the axes of analysis was put fixed point model-based autocode in fixed point, so to reduce the size of mainly the data. So core principle was to base on the grammar of the variable, and everything was defined in terms of data type via what I'm calling the software quantity. So that means when we generate the data dictionary or set the data point, everything was based on an implementation rule in order to set the data type. Result, we did most of the study based on a dual inverter with a TC397 and Infineon microcontroller. The feedback is that the microcontroller is quite well optimized already. The fixed point unit FPU is quite well performant, even has been well developed, even compared to the ALU. So for the same autocode with quite a work of optimization, we end up with 15-20% of reduction in CPU load, but not that more. However, the cost size was increased by 50%. For an inverter, that's not a big problem, in the flash at least, but in PSRAM it could be. So with just 20%, 15-20% reduction in the software, that was not significant to deploy that to the whole business. Just to give you an idea, so I was the only one working on that, doing one of the software components, the first one. And I would say the rest of the software design team was not up to speed with the method. So we decided that at least for this application, this microcontroller, there was not that many gain to do with the fixed point auto-coding. There is little, but not that many. However, in terms of calibration size, that was very useful, and we are implementing the storage of the calibration in fixed point, at least for the maps. Typically, we had some function that were related to characteristic for electric motors. So electric motors are like giving big maps, 50 by 50 variables. And for this one, we only with 15 of them, we reduced by 60 kilobytes the calibration out of about 2,000 label of calibration. So this one, fixed point storing of calibration is applicable right now for us. Next step. We have what we call, we need to develop the platform software, we say in a lateral way. So our next step will be to implement the platform software with different suppliers that will come next year. And also to have more and more products. Like I said in the presentation, for the next 5 years, we have a whole portfolio of inverter with motor, with configuration. And objective is to deploy this platform software on all the type of powertrain. Now also we have a new objective from the business is to, what I say, do a vertical deployment. So now we are in a big department in Changan, where we have 4 other domains we're doing in our software. So now we have been tasked of how to prepare and to work at deploying the same method and application for doing in-house software to the other domain, in idea to create a kind of a big library of in-house software for all the application. Mainly VCU, thermal management system, battery management system, and chassis. Example, now I'm coming back from Chongqing via our R&D center in China, and we are starting working with the chassis team on the electric power steering, because they bring also in-house power steering software. That is the next step for us. So still several years of development for this approach. And that's it. Any question? And just to check, on purpose, I didn't mention a specific acronym which this work related to. Maybe somebody spot it, where we are going toward.
But thank you very much for your interesting presentation. I should not stand with this microphone too near to the box. Questions from you. So if someone has a question, please raise their hand and also share the microphones that the people who are joining us online can also listen your question.
Yeah, thank you, Etienne. Martin Brüll from Scheffler. It remembered to me what you presented, what we invented 20 years ago, Autosar. Can you explain what's new? Now, at that time, we didn't speak about software-designed vehicle. It was named differently. The approach was the same.
Oh, yes, absolutely.
What's new?
Okay, so actually, there's nothing specifically new. We are applying actually Autosar. So we are really applying Autosar concept for the software architecture, the classic one. In a sense, we're using the ETAS toolchain, which is Isolar A, B, and RT. So it's Isolar. What is new is more the fact that we are applying basically what we apply in VMS into the world of inverter software. So Autosar was led by VMS, where they did this kind of commonization. I witnessed that when I was at PSA Peugeot Citroën in the year 2000. So now we are doing that in the inverter. Inverter software was coming for more advanced engineering, so that was siloed. There was not a lot of commonality, small number. And now that is becoming the mainstream powertrain, they want to also deploy a platform software for the inverter in order to decouple the hardware and the software in the same way.
Okay, which was the vision, and now it's coming reality, and that's the point.
Yes, yes, actually, it's coming reality. We're at the beginning. We start with inverter, and we have the target to deploy that in a larger spectrum into the Changan for software. Yeah.
Yeah, thank you.
Yes, also.
I'm doing your job.
I want to ask which is the main motivation to choose induction motor for the next project? Because we know it's an old motor, matured motor.
In terms of motor, by default, we're using more permanent magnet motor.
Yeah.
And also, we are thinking of using induction motor because induction motor basically can reduce the cost. We are thinking of that mainly for the generator motor when we create a range extender.
Yeah.
So it's more in term of cost for the motor, induction motor. And also, there is some advantage if you use a mixed in traction. So if you have an induction motor, one motor for traction, another one PMSM, is that in induction motor, if I remember well, you don't have back EMF. So that means it's easier to have a kind of non-operating motor.
Okay, thank you very much.
Hello, thank you. Interesting presentation. I have another Autosar question.
Yes.
For me, and maybe I'm ignorant, Autosar is nice as a tier one, so you can supply into lots of different organisations, and it kind of knits together nicely under a common framework. But you're not really in that situation, so you're supplying into a single customer, and the kind of downside of Autosar is the as I understand it, the per unit license fee that you pay to your Autosar provider. Is that how you understand it, or have I misunderstood something? And I'm just wondering how you see that fits with Changan's future.
Yes, so for us, we are the OEM Changan. That means when we go for Autosar, it's to have our in-house software compatible with multiple supplier environments. So even in China, most of the suppliers now are following the Autosar Classic architecture. So that means we have a portfolio of several suppliers, and if our platform software is Autosar compatible, we can integrate it without any modification. That's what we're looking for. Commonality to be able to have a compatibility with different suppliers. It's the purpose of the Autosar. Autosar is a business model. So that means everybody is designing the software in the same way. So you have a cross-compatibility between the supplier and OEM. So that is a solution to achieve the cross-compatibility.
Okay, thank you. So it's the other way around. So it's to be compatible with people supplying into you rather than for you supplying into.
Yes. Yes.
And do you develop your own Autosar framework? I think you said.
No. We're using. So no, I said we are in control by specification and definition. So just before to create the RT specification to compile, before that was done by the supplier. So when we do that internally, so that means we can reshuffle the number of software components, change the interface in our way, and design and add all the components we want. We are more in control of the software architecture, how to specify it. But we're not defining a new standard of software architecture. No, we're not at this level. We're using it.
Thank you.
Okay, then I would like to thank you for the presentation and also
Thank you.
for the answers. And then I would like to hand over to Quentin